Today we're starting a new unit. This unit is all about functions. So we're first going to learn how to identify a function. Fill out your table of contents. Your note sheet first has some vocabulary that you're going to fill out. A function is a rule that assigns each input exactly one output. Your input and outputs are really just your x and y values that we've talked about already using tables of values. A function specifically occurs when every x value, or input, is associated with exactly one y value, or output. To test whether or not a table or set of ordered pairs represents a function, we can look at each input, or x value, to see if it has exactly one output, or y value. This is an example of a function right here in this table. Each x value is doubled to create the y value. Remember, we could also call these inputs. If I input 2 and I double it, I get an output of 4. If I input 3, I double it and I get an output of 6. Typically, we would talk about the equation of that function, and we know that in order to get our y value, we said that we're going to take and we're going to double our x values. So later on we'll be talking more about equations that go along with the table of values that we have. We're also going to take a look at graphs again. If a graph represents a function, it should be able to pass what's called a vertical line test. This means that any vertical line drawn in the graph should intersect the graph at exactly one point. And that's because of the definition of function. Each x value, or input, has exactly one output, or y value. Let's take a look at some examples. The first example is a table of values that's horizontally laid out, so all your x values are across the top, and they're all different. So we can see that this x value has an output, this x value has an output, this one, and this one, and this one. Even though we have two different y values that match, the x values that they came from, or the input values, are different. So this means each input has exactly one output. This is a function. The next one is not a function. The reason it's not a function is because of the circled ordered pairs. This is a list of ordered pairs that we sometimes look at instead of having the values in a table. The first ordered pair has an input of -2, resulting in an output of 1. Down here, we see the same input, but a different y value. This is going against the definition of a function, so this is not a function. An input cannot have two different outputs. We're going to talk about the vertical line test now for these graphs that we have. If you take any vertical line, you could even take your pen, and you hold your pen over top the graph. You're going to hold it vertically. When you go across the graph, you're checking to see, does your graph cross this vertical line just once? It does there, it does here, it does in the center, and as you can see, it's going to continue to just cross my vertical line one point at a time. That's the definition of a function when you're looking at a graph. It does pass the vertical line test because it will only intersect the graph one point at a time. Now look at the next graph. The next graph is a curve similar to the first curve, but it's kind of facing the opposite direction. When you take your vertical line, do you see how it intersects more than one point on this curved graph? It intersects here, and here. We can move it over and see that it also intersects in 3 places over here. This is not a function. It does not pass the vertical line test because the vertical line test is there to help us see that we only cross the graph one point at a time, like this example. For number 5, think about what you're seeing when you take this vertical line across. This linear equation going straight through the middle is only going to intersect the vertical line one point at a time. This is a function. It passes the vertical line test. Now, sometimes we will have an equation. An equation represents a function if every input, or x value, will only result in one output, or y value. What we typically do is substitute various input values to see if an equation represents a function. So what I have for you first, for number 6, is the equation y equals x squared, and I put together a small table of values. The inputs I've chosen are -5, 0, and 5. When -5 is substituted into this formula, we would have to square it because it says the y value equals the x value squared. So when you take -5 and you multiply it against itself, you get positive 25. 0 squared is 1, 5 squared is also 25. But since every input has an output and only one output, this is considered a function. So on your paper, you need to answer the question, is this a function? And then you need to verify your answer and why you know it is. We said it's a function because every input has only one output. Now, the middle equation is a little more complicated. You need to find out what y is based on the fact that y squared equals the x value. So this time we're going to substitute in an x value of -9. And this gets very confusing because if you remember how exponents work, is there any number that you can square and come out to have a negative answer? I don't think there is. We'll try a different number. How about -3? Is there any number that you can square so that the answer comes out -3? I don't think that would work either. How about 0? If 0 is our input, your input is over here on this equation. If 0 is your input, and you have to figure out what number squared, this we can at least find a value for. We know that 0 times 0 is going to be 0. The last example is tricky also. How about if we tried, instead of 3, how about we try 4? 4 as an input, as an x value, can be found a couple ways. You can find 4 if you start out with 2 and square it. But couldn't you also put a -2 in here? The fact that we were able to come up with 2 different y values to make this work out tells us right there it's not a function. The other reason we know this is not a function is because we weren't able to take any numbers, square them, and come out with a negative answer. So if your inputs do not have exactly one output, it is not a function. So this is no. Each input does not result in only one output. The last example is also a little crazy. First, we're going to start out with an input of 3 squared. 3 squared means 3 times 3, or 9. This value then must be 16 when you total it up to get an answer 25, so that's why we have to go with 4 squared. Keeping track of how numbers get squared, couldn't we also start with an input of 3 squared, but use an output or y value of -4? -4 is also going to give you the 16 that you need for this equation to be true. So right here is enough information to show that each input does not have exactly one output. So this is an example of something that is not a function also. What I need you to do is take a look. You can pause the video, see if you can go through the rest of these examples to figure out if these are functions by saying yes or no, and then coming up with a solution. And then play the video to check your answers. Okay, time to check your solutions. For number 9, each input has exactly one output. Again, it's okay if all the outputs are the same number as long as you don't have any repeats with your x values. 3 goes to 7, 4 goes to 7, 5 goes to 7, 6 goes to 7. As long as we don't have any more inputs of 3, 4, 5, or 6, we're good to go. That's why the second question, number 10, is not a function. You have an input of -7 that gives you this output of 1, and then there's another input of -7 that gives you a different solution. So what we're looking for when we have a table of values or a set of points is we're actually looking to see if you've got multiple x values that give you a different output. This one will give you a different output each time. So every input has only one output. You're going to take your values, you're going to square them, you're going to add 36, and you're going to get a unique or only one output for each x or input that you plug in for number 11. Remember to use your vertical line test. If you have a line drawn, you can easily take it, or better yet, just use your pen. Take your pen and move your pen across the graph to verify that your vertical line will only cross your graph one point at a time. And you got to focus on it crossing the graph, not necessarily the x and y axis. You're looking just to see where the graph crosses your vertical line. And with this example, it does pass the vertical line test, so it is a function. For 13, we are looking to see what repetition we have. We have an input of 9 giving you the output of -15. And then way down here, you have another input of 9 giving you a different output. And that is not what we're looking for when we're identifying a function. The last example, y squared is going to equal 49 minus x squared. This is a lot like the other one example where we had the x squared plus y squared equaling 25. We can use positive values here, but we can also use negative values, and it would work out, and you would end up with more than one output for your input. So this is not a function. Each input does not result in only one output. This page will get folded and put in your notebook in just a minute, but I want to make sure you know what goes on your other page. Your other page, the sheet says that it's homework. I'd like you to try to do this now in class, and then we can get them folded and taped in today. You're identifying functions. You're going to do a couple practice examples like we just talked about, and you're going to use what we've learned about functions to see if you can tell, is it a function, yes or no, and then justify your answer. Pause the video, do the practice questions, and then check your answers before I have you tape this in. Okay, check your answers. Number 1 is a function because each input has exactly one output. Number 2, yes, it's a function. Each input that you put in will get a unique output. And the third one is not. If we take a vertical line and we go across, we will see that the vertical line intersects this circle or oval in two different places when you place the vertical line here or here or here. So this is not a function. For number 4, it's not a function because we have a 13 input that gives a 4, and then we have the same input that gives a different output. So this is not a function. The input of 13 has two different outputs. This is similar to the other one we talked about because of the y squared. An input may result in more than one output. For the vertical line test on the graph, if you take your vertical line, it's going to intersect once, and if you move it over, it's only going to intersect once all the way across. So this does pass the vertical line test. It is a function. And the last example is no. You've got this input of 25 giving you different outputs in both examples, so it's not a function. Take both papers now, fold them in half. Your initial notes with all the vocabulary goes on this side, page 83. The notes, or the page that says homework that I had you practice in class today, gets folded in half and taped into page 84. Make sure that these open up so that you can easily study your terms and examples in the future.